Okay, let's give you guys some examples. So in this video, we're going to use a ratio test to determine if this alternating series will converge or if it will diverge. So we need to obtain an plus 1 divided by an. So looking at this, this is your an plus 1. This is your an plus 1. And then this here is your an. Because we are looking at this at the moment. So to obtain your next term, you need an plus 1. So you've got to put this into the n, and then you've got your plus 1 here. You've got your plus 1 on the outside, and then for this bit here, you need to put, to obtain your next term, you need to put an plus 1 into just the n here, So this is your an plus 1, and then you've got your squared, and then you need to do the same here. So n plus 1, you put it into the n, just the n here. So it would be 2 to the power of n plus 1. So this whole thing here is your an plus 1, and then this here is your an. So basically we've got this here. This an plus 1 here is this whole thing here, and then this an here is your an here. Okay, and we because we're taking the absolute value of the whole thing here, if you look at it, this thing here, this block here, will either be a negative 1 or a 1. And then if you look at this thing here will either be a negative 1, a negative 1 or a positive 1. Well, either way, it doesn't matter. We can just get rid of it because we're taking the absolute value here. So we can actually just discard this block here. We can just discard this, and we can just discard this. So from here, that will then take us to here. But when you come to do this by yourself, just in your mind, jump. Well, when you come to do this by yourself, just jump straight to here. Immediately discard this, because you know you're going to take the absolute value of the whole thing. So in your mind, discard this. So when you come to obtain your n plus 1, discard this in your mind. So looking at this here, hang on. So when we did it earlier, from here, we actually kept this thing here. We actually kept it here. This thing and this thing here. But when you actually come to do it on your own, immediately discard this, because you know you're going to take the absolute value of the whole thing. So this is just going to make it positive 1 or negative 1. Immediately discard it. So just concentrate on obtaining your an plus 1, and then obtain your an here. So this here is your an. This here is your an plus 1. And then also remember this thing here is from 1 to infinity. So n is from 1 to infinity. Looking at this, it will never be negative, because you're going to square it. This thing here will never be negative. 2 to the power of n looks something like this. 2 to the power of n. Well, this thing here is not going to be negative. So this whole thing here will never be negative. And then as n travels from 1 to infinity, this is never going to be negative. This is never going to be negative. So you can actually discard the whole absolute sign as well. Okay, so when you come to do it, immediately discard this. That will then take you to here. And then here, have a quick glance. You can tell that it's never going to be negative. So you can actually discard the absolute signs. So it will then become this. So hang on. So remember, we're going to discard the absolute sign here. So here we've got one fraction divided by another fraction. So we've got one fraction divided by, well, that's the same as times in the reciprocal. So turn this upside down, take the reciprocal. So that will then give you this. So now if you look at this, this thing here is really 2 to the power of n times 2, or 1 if you want. Well, it's going to be this, and then this 2 this 2 to the power of n here will get cancelled out with this. So so merging these two together will just give you this block here. Okay, and then this stays the same, that stays the same, stays the same, and then multiply this out. This whole thing here will then become this. This whole thing here will then become this. So remember, we are trying to find the limit as n tends to infinity of this thing here. Well, as n gets bigger and bigger, hang on, as n gets bigger and bigger, the numerator will just act as n squared, because as n gets bigger and bigger, as n heads towards infinity, these two will be irrelevant in comparison to n squared, because n squared is a lot more significant. It's a lot more, well, it's going to be much bigger than 2n and 2. So it's just going to act as n squared. And then looking at the denominator, as n gets bigger and bigger, this 2 here is going to be irrelevant. It's just going to act as 2n squared. So now it divide everything by n squared. Well, it's going to the limit will be a half. So remember, this limit of the half. Remember, we are talking about the limit of the ratio. We're not talking about the limit of the sequence itself. What if you have a limit of the, when you take the ratio and the limit is 1? If the limit is 1, all that it's telling you is that the graph or the sequence is flattening out. That's all that it's telling you. Because when you get the magnitude here divided by the magnitude here, let's say the magnitude here is 3. If you have a limit to be 1, then all that it's telling you is that it's flattening out. Here we've got a limit of a half, so that's like oh, this magnitude here is 1, this magnitude here is 2. So when you get the next term divided by the current term, an here, so that's like, yeah, all that it's telling you is that it's going downhill. If you have a limit, remember, we are not talking about the limit. We are talking about the limit of the ratio. We are not talking about the limit of the sequence itself. We are talking about the limit of the ratio. Or if you have a limit of ratio equaling 1, then it's just flattening out. If it's less than 1, it's going downhill. If it's bigger than 1, for example, let's imagine this to be 3, this to be 2. So when you get the next term divided by the current term, that will be 3 over 2, which is bigger than 1. The limit of the ratio being bigger than 1 is telling you that it's climbing, it's getting bigger and bigger. So remember, limit of a half actually tells you that it's, well, we don't know what's happening out here because the limit is heading towards infinity. So right at the tail end of things, the limit here is a half, meaning it's going downhill. Okay, so looking at the theorem, if the limit is less than 1, the theorem says that it converges, and we don't know why. We don't, at this stage, we don't truly understand why. It's just a theorem saying that when you take the limit of the ratio and the apse, if it's less than 1, we don't know why at this stage. We just know that the original alternating series will actually converge. That we don't truly understand why it is that when it's less than 1 it converges, but the theorem is saying that. Okay, hopefully in the future we will understand why.